Financial modeling, topic 9, bond valuation, yield to maturity, duration, convexity, and bond VAR. References include Financial Modeling, 4th edition by Simon Beninga, chapters 20 and 21. Section 1, we're going to value bonds and compute yield to maturity. Future topics, we'll discuss duration, convexity, mortgage durations convexity valuation, compute the VAR of a bond, and use Excel's built-in bond functions. The fundamental value of a bond, we'll call it V, is the present value of all expected cash flows. That can be written as the sum from I equal 1 to T times F, each cash flow at time T, or time I, discounted at some rate R. Let's talk a little more about this function, or this formula. Basically, the cash flows for a bond are going to be paid periodically, and they'll be either coupon payments or the par payment at maturity. So I is going to refer to the timing of the cash flow, and that cash flow is going to start in period 1 and continue to T times F. Now T is the maturity of the bond in years. So say we have a 5-year bond that makes, say, two payments per year. So F is going to be our frequency of payments per year. T is a maturity in bond. So if you take 5 times 2, this 5-year bond that makes 2 payments per year will make 10 payments. So back to our formula, we're going to count the cash flows from 1 to 10 for that 5-year bond that makes 2 payments per year. And at each point, we're going to get the cash flow, which will either be a coupon payment or a coupon payment plus par. And we're going to discount it at some rate R. R is going to be an annualized discount rate. So we're going to have to divide it by the frequency to get a periodic discount rate. So for example, in our case, which I've just mentioned, is a bond that takes 2 payments per year every 6 months, makes a payment. We're going to discount that at a 6-month discount rate by taking the annualized R and dividing by 2 and raise it to the I power. One other note on this R. This R is also called the yield to maturity when the present value of those cash flows are equal to the market price of the bond. So let's use that formula to value 2 bonds. Bond 1 is an annual payment 5-year bond, has an annual coupon rate of 10%, a discount rate of 9%, par of $1,000, and frequency of 1. We'll then value bond 2, and the only difference between these two bonds is bond 2 makes 2 payments per year instead of 1. So let's go ahead and go to Excel and value these bonds. So we're going to first look at our periods. The present value of the bond is the sum from I equal 1 to T times F. So in this case, when there's only 1 payment per year, the frequency, there are only 5 total payments. So I've listed periods 1, 2, 3, 4, 5. Each period is going to pay a coupon. So we'll take our annual coupon rate, I'm going to anchor that, times our par, I'm going to anchor that. So this bond makes a payment of $100 every year. And at maturity, it's going to take that coupon and add the par. So this bond makes 5 payments of $100 and 1 payment of $1,000. I'll discount those cash flows. I'll take 100 divided by 1 plus my discount rate, anchor that, and raise it to the I power. Let's divide it by frequency first, which in this case doesn't have any effect because you're dividing by 1, and raise it to the I power. So the present value of $100 received the present value of $100 received 1 year from now, discounted at 9% is $91.74. I'll copy that down. I'll sum that up. And you see the present value of those cash flows is $1,038.90. In other words, if I bought this bond, received these cash flows, and wanted to earn a 9% return based on the riskiness of this bond, I'd pay exactly $1,038. And if I did pay $1,038.90 and did receive these cash flows, I would have earned 9%. Now let's look at bond 2. Now bond 2 has 10 payments. It's 5 years, 2 payments per year, 10 total payments are listed right here. So the cash flows in this case are going to be the annual coupon rate, anchor that, divided by the frequency. So this bond is going to receive 5% of par every 6 months instead of 10% of par every year. I'll then multiply that times my par. And what this bond receives is $50 every 6 months. So each one of these periods is a 6-month period. That last one, we're going to add back the par. So both these bonds make the exact same amount of cash flows. This one just happens to pay it 6 months apart and not 1 year apart for the coupon payments. I'll then take the present value of cash flows, $50, divided by 1 plus my discount rate, anchor it, divided by the frequency to turn that into a 6-month discount rate and raise it to the I power. So the present value of $50 received 6 months from now is $47.85. I will sum that up. And what you see here is I'd pay $1,039.56 for this bond. I'd pay a little bit more for this bond that has these payments that are happening a little bit sooner, right? The first payment is received in 6 months and not a year from now. So that's how we value bonds. We take the present value of all future cash flows and making sure we account for the frequency. Now I've written a function for this, which is actually found in the textbook if you want more information about it. I've modified this function a little bit, but let's look at this function. This function is called bondval. It has 5 parameters: the annual coupon rate, the par amount, the maturity in years, the frequency of payments per year, and the discount rate. I first calculate how many total payments are there. So I have a variable n is equal to t times frequency. And then I have a loop for I equal 1 to n, next I. And then I have an aggregation function here. Bondval equals bondval plus the coupon times par divided by frequency over 1 plus r to the I. So what this is going to do is take the present value of all coupon payments. Once that is done, the only thing left to do is handle that last par payment. So my last statement, bondval equals bondval plus the present value of par. So this function calculates the value of the bond. We'll go back to Excel. I can hit Alt F11 and see the function right here. There it is. I'll insert it down here. So let's go ahead and put bondval in. So I'm going to insert, user defined, bondval, and I'll put in the coupon rate, the par, the maturity in years, the frequency, and the discount rate. And there's my $1,038.90. I'll do the same one here. Insert my function. User defined, bondval. I'll put in the coupon rate, the par, the maturity, the frequency, and the discount rate. And there's my $1,039.56. So there's the function. Well, it looks like a little extraneous variable there. Let me just scribble that out. So there we go. That's a function to calculate the value of a bond. So for the rest of this course, you never actually have to build a spreadsheet that looks like this to value a bond. We now have bondval. Last thing I want to do is talk about yield to maturity. Now, yield to maturity is the discount rate we've been using, R. However, YTM is the discount rate that equates the market price of the bond with the present value of the contractual cash flows. In other words, when we did this calculation, we said we wanted a 9% return, therefore we would pay $1,038 or $1,039 for these bonds. If this is actually the market price of these bonds that you observe, then we call that R the YTM, and that becomes the yield, the yield that you will earn if you buy the bond and the bond does not default and you receive those cash flows. Now, one other way of thinking about the yield to maturity is the yield to maturity is also the IRR, the internal rate of return of the bond investment, buying at the market price and receiving those contractual promised cash flows. So what we're going to do is we're going to calculate the YTM of bonds 1 and 2 if they're actually selling for 1,045 or 1,047. So let's go back to the spreadsheet. I have a link down here that says if this first bond is selling for 1,045, and that is your cash outlay for the purchase of the bond, and then you receive your coupons and your par, these are the cash flows of the bond. If we simply then take the IRR of the cash flows and multiply times the frequency, we can see that if we pay 1,045 for this bond, the YTM is 8.848%. And you can think of that as the rate of return you're earning if you pay 1,045, with the caveat that the bond does not default and you're able to reinvest your coupons at that yield to maturity. Now, just for fun, we could say, what if we did pay $1,038.90 for the bond? Now you'll notice that the YTM is 9%. So if the present value of the cash flows is equal to the market price, if the bond is actually selling for $1,038.90, then that R, that discount rate, is also the YTM. But I'll hit undo. Now the second bond, what if that second bond is selling for $1,047 and you receive all these cash flows? I'll just copy my formula. Whoops, got to add a few more cash flows there. Times the frequency. In this bond, if you pay $1,047 for this bond, receive all these cash flows. It does not default, and you reinvest these coupon payments at this YTM, at this discount rate. The YTM, or the rate of return you will earn on that bond, is 8.817%. So that's why you can think about the YTM as a discount rate. You can also think of the YTM as an IRR of a bond investment. So in this topic, we talked about valuing bonds and computing YTM. In the next topic, we'll talk about interest rate sensitivity of bonds and duration.